Well, hello, honors geometry students, and welcome back to some more online geometry. First, just let me thank you for all these wonderful jokes. You heard them, I've told you these jokes. Okay, let me go with a few of the ones I thought were really funny. Why couldn't the angle get a loan? Why couldn't the angle get a loan? His parents wouldn't co-sign. But my favorite was that one, what would that one said? Ever heard of the mathematician who's afraid of negative numbers? Ever heard of the mathematician who's afraid of negative numbers? She'll stop at nothing to avoid them. Okay, well, we better get started here today. Well, my friends, we are going to be getting down to the countdown now as we go into 12.6 and 12.7. Next week, we will have a video on an extension for 12.6, but I think it'll be a kind of short way to end the year. Okay, at 12.6 and 12.7 really don't have as much review in as the last couple of sections, so I think you'll find them to be a little easier also. So let's hope so. But when I was looking for this, I thought, oh, there is one thing that I left at school that I wish I would have brought. It's a newspaper clip article about Mike Tyson. Do you guys know Mike Tyson? This guy does. He says, yes, I know Mike Tyson, okay? Mike Tyson was a boxer a long time ago, so I don't know, maybe you don't know him. Yeah, I think some of you know him. But he did end up in jail. We won't go into why he ended up in jail. But while he was there, he took a GED, and one of the questions on the GED pertains to the lesson we're going to learn today. The question was, if x squared plus y squared equals 34, what's the radius of this circle? If x squared plus y squared equals 34, what's the radius of this circle? Now, Mike Tyson in the interview in the paper said, anyone who knows the answer to this must be a rocket scientist, okay? So I'm really kind of here today to find out, do I have any rocket scientists in my midst? I think I do. Let's go ahead and get started. Okay, 12.6 is working with segments. So we've been working with angles. So 12.6 is going to be looking at segments in relationships to circles. So we're back to segments. Of course, that means that they're going to be measured in inches or centimeters, something for segments, where all those arcs had all those degrees. Forget about all of that, okay? I wanted to start with a review just so that you remember this as we get into the segments here today. So a couple of things to review. Remember when we were working back in chapter 7, if we had triangles similar, one of the ways we could get them similar was by angle similarity. And if they were similar, that you could take the first two over the first two, so AB over XY is equal to last two over last two. And of course, it could also be equal to AC over XZ. And that's just the definition of similar triangles. But the point here today is once I get them to be proportional sides, then what did we do? We used the cross product, or we cross multiplied, okay? So just a little quick review on that. Also a quick review on, we really also had part of this before. If you have tangent segments, then I already know the part equals the part. Now again, we're not going to do a heavy proof in this, so we're going to go with just the abbreviated form. On your reteach worksheets, those theorems will all be written out for you. But right now we're just looking at two tangent segments, part equals part. So if I needed to solve that, I just set those equal to each other. It would not be the new part in our 12.6. So we have worked with some segments before. Okay, let's take a look at the new part then. In the new part here then, we're looking at saying, I want to be able to find x in these segments. And so you see that they're not two tangent segments. In fact, what are these segments DF and HG called? They are chords. And what we're going to be looking at is really what we just went through as the review. If I make these into two triangles, obviously those two triangles are not congruent, are they? But are they similar? Okay, very good, because I would have, let's get a different color so you can see it a little bit better. I would have vertical angles congruent, so I would know that these are congruent. But remember, I would need to have those two angles. So what other angles would I have? Okay, very good. So if you're looking at H, its vertex is on the circle, and it has two chords of the circle, and so it would be an inscribed angle, and its intercepted arc would be arc DG. Because an intercepted or an inscribed angle equals half its intercepted arc. So angle H would be half of arc DG. Now you see where we're going with this? Is there any other inscribed angle that has the same intercepted arc? You're seeing it. Okay, very good. So then what can you say about angle F? Well, angle F is half of arc DG. Angle H is half of arc DG. And so two inscribed angles with the same intercepted arc would have to be congruent. So the point is that yes, I would have a triangle DEH similar to triangle GEF. And of course that would be by angle similarity. And once I had those triangles similar, then what could I say about their corresponding parts? DE would have to go over, exactly right, GE, first two over first two, and then EH over EF, exactly. And that would just be by the definition of similar triangles. Okay. Now, of course, you could say DH is over GF, but we put those in, so we didn't really need to use those at all anyway. Then what am I going to do? You're exactly right. I'm going to cross multiply. Now, take a look at what we really did, because you won't be doing all of this on your homework. I just want you to see why this works. So to help you remember what I have here as well. Because the lesson then is really very, very simple, especially since I'm not writing out all the words. If I have two chords that intersect somewhere inside the circle, then all I do is part times part equals part times part. Literally, that is all you're doing. So on this problem, if I said find x, I would not do any of this. This is just so that you know where it came from. It's not some magical thing here. We need to understand it. I'm just going to take DE, which is x, times EF, which is 5, and set it equal to GE, which is 4, times EH, which is 3. So notice how easy it is. You go along one chord and you multiply the two pieces of the chord. And then that equals, go along the other chord and multiply the two pieces of the chord. So you don't need to see any of this on your homework. You just need to write this equation and solve. So I have 5x is equal to 12, x is equal to 12/5, and you can even leave it as an improper fraction. So very, very easy day. Chord theorem. Part times part equals part times part. Now, we'll write that out more completely in the reteach worksheet. That'll be in there. Okay, but let's go ahead and take a look at this and make sure we've got this. So we're working again with segments today. So now you can see that, okay, yeah, I've got those segments. That would be two chords. So yeah, this would be very easy then, won't it? I'm just going to do 4 times x, go along one chord, and then 14 times 5, go along the other chord. Whoops. Okay. So really very, very easy day. So all we're looking at then is 4 times x, 4x is equal to 14 times 5 would be 70, and x is equal to 70/4. Now you can leave it improper, but remember you do have to simplify. So 35 halves, and you can leave it just like that. Now I put this one on here because I wanted to look at what happens if I give you not the length of AB, okay, so let's erase those, and I say, okay, this is 14 and this is 5, but all I know is AB is 17, and I want you to find the two parts, okay? So now the directions change. Instead of finding x, you want to find the two parts of segment AB. Okay? So think about that. How am I going to find the two parts of segment AB? Okay, well, to find the two parts of segment AB, we can use some algebra. And our algebra is going to end up then exactly what you had from before. Let one of those be x, and then the other one would be what? 17 minus x. Because x plus 17 minus x would add up to 17. So then I just do exactly what I said from before. X times 17 minus x, part times part, and then go along the other one, 14 times 5. Okay? So it doesn't change, you just have that little bit of algebra to do. But now what happens when I distribute that? We're back to a little algebra review, because now I'm going to get an x squared. So what do I have when I have an x squared? A quadratic equation. So I set it equal to 0. Let's keep the x squared positive. And how do I solve a quadratic? See, you got to remember all these little things for next year. I'm going to solve a quadratic by factoring. So x times x makes x squared. Go to a positive 70 to get a positive 70 and a negative middle term. I need a negative times a negative. And then factors of 70 that add up to 17. Oh, well, that's just going to be 7 and 10. Okay, so that means that x minus 7 equals 0 or x minus 10 equals 0. And so I have two possibilities, either x equals 7 or x equals 10. So then what are my two parts of AB? Well, if x equals 7, then this is 10. Or if this is 10, this is 7. So the two parts are 10 and 7. Okay, so a little bit of review in that, looking at the quadratic formula. Okay, now we have one other thing that happens. What happens when I want to find x, but this time I've got two secants, okay? So now I've got two secants instead of my two chords. So now how am I going to find x? Okay, well, let's just say this is 5 and this is 10 and this is, so let's say this is 4 and this is x. Okay? Now, I'm not going to go through this, but you really are using similar triangles just like you had in that last one. You're really looking at putting these triangles. So if you made that chord in there, you see how you have your triangle here? Oh, look what you have in your triangle. One part of your triangle is out here, 4, and the other side of your triangle you have to add together, okay? So that's what you're going to be looking at here, and if I put it in this way, it's going to be the same thing. One part of your triangle is 5, and the other part I'm going to have to add together, okay? So basically what you're looking at here is when I have the vertex on the outside, so I'm looking at two secants, or a secant and a tangent, then I'm going to be looking at a different formula. I'm going to take the part outside times the whole segment. So that may mean that I have to add it together, okay? And then I do the same thing on the other secant segment. I'm going to take the part outside times the whole segment. So I told you it's really not too bad today. I'm just doing part outside times whole equals part outside times whole if I have a secant or if I have tangents involved, unless they're both tangents. So this is when I'm working with tangent, one tangent, and one secant or two secants. So we'll put an apostrophe S on that. Okay? Now again, it writes all out in your notes or on your reteach, so I'm not going to write it all out, but these are really what I want you to remember today. Part outside times whole, part outside times whole. And here part times part equals part times part, and then we had the other one before, part equals part. So that's really 12-6 in a nutshell. So how am I going to work this then? I'm going to take the part outside, 5, times the whole thing, 5 plus 10, equals the part outside, 4, times the whole thing, 4 plus x. So remember, you might have to add that together because of your similar triangles. okay? So then I just go ahead and multiply that out. So 15 times 5 is 75. 16 plus 4x, don't forget to distribute there. So subtract 16, 59, isn't that right? 59 equals 4x, and divide by 4. So 59 fourths. Okay? So not too bad, but there are big ideas here today. So make sure that those make sense to you. Okay? Now let's take a look then at a little algebra review on that. What happens in a problem like this? So now we can see our example here of saying, okay, here I've got a tangent and a secant segment, okay? My vertex is still on the outside, so I'm still doing the part outside times whole equals a part outside times whole. But now my part outside, when it's a tangent, is the same thing as the whole. So that means I'm going to take the part outside, x, times the whole thing, x. Or in other words, when it's a tangent, you really just square it, okay? Unless they're both tangents, then you just set them equal to each other. So part outside times whole is x times x. Do the same thing now on your secant segment that we just did on the whiteboard. So that would be 10, the part outside, and then the whole thing, 10 plus 15. That makes sense? So it's still the same thing, part outside times whole equals part outside times whole. I like to make this as easy as we can. So of course then we have a little more algebra review. 10 plus 15 is 25. 25 times 10, 250. Now how do I do this algebra review? Well, remember we're going to simplify our radicals so we have exact answers. So I'm going to take out a 25 and my end answer then, 5 square roots of 10. Okay, so just reviewing a little bit of algebra in that, and it wouldn't be too bad. Okay, that is 12-6. So any questions on that? Well, Mike Tyson comes up in the next example. We're going to get back to that. I haven't forgotten today. I knew I forgot that last week. But Mike Tyson will come up. Well, yeah, he might be hungry. He might want some chips. What do y'all think? Okay? So now let's figure out if x squared plus y squared equals 34, what is the radius of that circle? Okay, and what you're going to find is it's actually easier than 12-6. So 12-7, our last in the textbook here today, is circles in a coordinate plane. Okay, so today we're going to be looking at if that x squared plus y squared equals 34, what is the radius of this circle? So if we just said, well, let's just start off with a coordinate plane and get one that's already graphed. So we already know the circle has a center of 2, 3, and we already know it has a radius of 4, and so then I graph my circle, assume that's a circle, I left my compass at school. Okay, and now we're going to say, how could I find the equation of this circle? Because it says write the equation of this circle. Well, first of all, what is the circle? Is the 4 on the circle? That's inside the circle. Besides this point, nothing else is on the circle, because remember the circle has to be just that caved part, okay, that curved part. So really, how many points are on the circle? You're exactly right. Any point out here would be on the circle. And any one of those points we could call x comma y. So I could call this point x comma y, or this point x comma y, or this point x comma y. And it wouldn't matter, because as soon as I drew in the radius, if this radius is 4, would that radius be the same? Okay, so I could make it wherever I want. So let's just go ahead and use the picture as there and say I've got x comma y. Now take a look. You have 2 points, and you know the length of those 2 points. What are we really using here today? I told you, it's not anything new. We're really just using the distance formula. D equals difference of x's squared plus differences of y's squared. That's really all the equation is. So the equation of the circle is really just a matter of the distance formula. Okay? Now, how is that going to apply? Well, we just put in the numbers that they gave us. They gave us the distance. The distance is always the length. So they said, okay, 4 is my length. And now I have 2 x values. So I just do the square root of the difference of x values. So let's start with that one, x minus the x value here. Got it? And now plus, and now I just subtract my y values. Now, technically, they don't like to have a square root in the answer, so how would I undo square roots? Exactly, square both sides. So the answer to my question, write the equation of this circle, is just 16 equals quantity x minus 2 squared plus quantity y minus 3 squared. Basically, the distance formula. So a very, very easy lesson in 12.7. All I'm doing is basically the distance formula. So we expand it just a little bit and say, okay, that makes my equation of my circle then be my radius. Well, my radius was 4. So what do I really do with it? Square. So radius squared equals, subtract the x values. Now, your Algebra 2 books will put in a different variable for that x value. You can see it's the x coordinate of the center, so they're going to call that h. So we're going to use that same variable. So r squared equals x minus h squared plus y minus, and they're going to call the y value of the center k. So we're looking at r obviously being the radius, and the point H, comma, K actually being the center of your circle. So this is essentially the big idea in 12.7. The equation of a circle, r squared equals x minus h quantity squared plus y minus k quantity squared, where r is the radius, h, comma, k is the center. That's the big idea. Make sure you've got that. Now, let's just make sure we've got it, because it should go pretty quickly on this before we get into a little bit of review. So all we're looking at here then, it's going to be very, very quick. I take my radius and I square it. So I just say 1 is equal to, and then I use my distance formula, x minus whatever my x value was. So x minus 3 squared plus y minus 6 squared. That's my answer. That's all I have to do. Okay? What happens when the center has a negative number? What happens if one of the variables is 0? Okay? Well, I start still with my radius. My radius squared would be 49. And now I'm going to do x minus my center. When I do minus a negative, what does that become? Exactly. So when it's minus here, I'm going to have plus here. So remember, you're basically doing the opposite of the center. What happens when that's 0? You just put it in. Y minus 0 squared. Would I even have to write y minus 0 squared? No, I could just say, oh, that's the same as just y squared. And there's my answer. 49 equals the quantity of x plus 2 squared plus y squared. What happens if the radius is a radical? Well, when you square it, what happens to your radical? It just disappears. So your answer there would simply be 5 equals, and then remember to use your opposite signs. So x plus 4 squared plus y, this one's positive, so because of my distance formula, it becomes minus 8 squared. Whoops. And that's it. So if you have a radical that is a square root, you just square it, and it isn't a square root anymore. Whatever the signs are, you just use the opposite. If it's 0, you won't have anything subtracted. Okay? So anybody have an idea now as to the answer to Mike Tyson? Do I have any rocket scientists in the midst? Yeah, you can probably figure this out now, right? Because if x squared plus y squared equals 34, that means that r squared was what number? Exactly. So what is the radius? And Mike Tyson thought that that was a really hard question. Okay, it's all about the math you know. The more math you know, then you can start thinking deeper and deeper. Okay? It didn't ask for the center here, but does anybody know what the center would be? Well, what's being subtracted? okay? So it was a pretty easy basic equation of a circle if you understood the equation of the circle. Now the last thing that is the easy part of the assignment is just going backwards from all of that, and then we'll take a look at an example where I have a little review in it. Okay, and that is what happens if they ask me to graph. But it's really just going backwards of what we just did. So not too much difficulty at all. I know that, oh, is my radius 9? Okay, remember that's not the radius, that's my r squared. So if r squared is 9, the radius must be 3 because my square root isn't over it. What about my center? What would my center be? Remember to use the opposite signs. If there's nothing being subtracted, then you have 0. And would that be positive 1 or negative 1? My center is 0, negative 1. So all I'm doing is going from 0, negative 1, and then going out 3. And you can do that with a compass if you have one. I don't have a compass with me here. And then if you don't have one, no excuses, just sketch it. Okay, and tell me what that is over here. That's really all it is, just going backwards. Let's try one more, make sure it makes sense before we try one with a little bit of review. Okay, so we have x minus 5 quantity squared plus y plus 1 quantity squared equals 1. What's the radius? The square root of 1, which is just 1. What's the center? Very good. Opposite signs, so 5, negative 1. And that's exactly what you do. 1, 2, 3, 4, 5, negative 1. Go out 1 in every direction. And there's my circle. Okay? So really the heart of it, I told you it actually gets easier instead of more difficult. So the heart of it is just a matter of saying you've got to know the equation of the circle. So how are we going to get some review in it? Well, what happens if they don't give you the center and they don't give you the radius? What you can do then? What happens if I say I want to write the equation of the circle? I'll abbreviate that here now. If the end points of the diameter are given. So think about that. What would I do if the end points of the diameter are given? So let's say the end points of the diameter are negative 3, 2, and 5, negative 6. Well, you really think of it just the same as what we did with our equations. In our equations, I kept going, find a slope, find a slope, find a slope. And then you had to find a point, okay? Well, now we're saying, find the center, find the center, find the center, and find the radius, okay? So how are we going to do this? Well, we can kind of look at it a little graphically if we want to. Say, okay, I have a diameter at negative 3, 2, and 5, negative 6. Oh, that kind of gives us an idea. Where would the center be? Exactly. The center is just going to be the midpoint. So remember to find the midpoints. I told you just stuff that you already know. You just add the 2x values, divide by 2. Add the 2y values, divide by 2. So my midpoint would have to be what? 1, negative 2. Exactly. Now, is that enough? Because that's now my center. You're exactly right. I now need my radius. Now you could do that in a couple of different ways. You could find the diameter and then take half of it, but especially if it's going to be a radical, I would just assume that you just said, oh, the radius is just the length between these two, or these two, either one. Okay, so my radius is the square root of 5 minus 1 squared plus negative 6 minus a negative 2 squared. So my radius is the square root of 4 squared plus negative 4 squared. Remember when you do negative here, negative times a negative makes it positive. So my radius is the square root of 16 plus 16, or the square root of 32. Now, I would not take the time to simplify that unless it asked for the radius. Because remember now, to get my answer, I have to write the equation. Okay? And so I have people on a quiz on this section that'll get the right radius, they simplify it, and then when they square it, they miss it. So just leave it the square root of 32 so that my answer when I square it is just 32 equals x minus 1 squared plus y plus 2 squared. So remember, opposite sign, square the radius. And that's my answer. So you can see how there's going to be some review in today's lesson, but I think that it's really not too bad. And next week we'll only have one lesson where we're looking at a different form of the equation of the circle, which has always been on the end of course exam, but you don't have to take that, of course. That will not be on the quiz. So this week is just a discussion post. Next week we'll have our last quiz, so that'll be before Memorial Day. I forget the date of it, but that Wednesday before Memorial Day. And that'll cover sections 12.4, 12.5, 12.6, 12.7 from the textbook only. Okay? Remember, you can call or email anytime. I miss you all greatly. I hope to see you in the fall. Come by and see me, and hopefully we can get back on track soon. I will see you next week in our last video. Next week, we're coming down to the wire. Have a good week.